Hello, everyone. Welcome to CloudWorld and the session on achieving database operational excellence. Hello, I am Riaz Kapadia and work as Master Principal Cloud Architect with Oracle's Cloud Infrastructure team. It's a great pleasure for me to introduce our speaker today, who is going to talk to us about NVIDIA's journey into standardizing their database platform on Oracle. We all know NVIDIA has pioneered accelerated computing, and their work in AI and computer graphics is transforming industries from gaming to healthcare to transportation and profoundly impacting our society today. When you get associated with NVIDIA, you realize that this pioneering approach is present in every aspect of their day to day operations. And database is the heart at this, which makes it run as one homogeneous engine, irrespective of whether it runs in on-prem or Oracle Cloud. Our speaker today has spent more than a decade in this environment, and he is best suited to take us through this journey of integrating Oracle Cloud into NVIDIA's ecosystem. Please allow me to welcome Chris May, Senior Manager, Database Management at NVIDIA.
Thank you, Riaz. It's a pleasure to be here to speak about this journey that we've gone through. When I joined NVIDIA 15 years ago, it was already established as a leader and pioneer in the world of discrete graphics processing units. In the years since, the company has grown into and even invented new markets. Visual computing has grown far beyond the realm of gaming industry, and we're now integral to movie and other broadcast productions, 3D rendering, and now Omniverse. We're leading supercomputing, AI, scientific, and medical research. All of this is built on an ever more complex and innovative technology stack. As in any business today, nothing happens in any of these areas without data. Operational data ensures things like the bills getting paid and our paychecks getting processed. Security and communication applications rely on their own data sets. In addition to these common use cases, NVIDIA has an ever-growing set of specialized tools that people who are much smarter than me use to deliver services and products throughout the world. Helping them is where I contribute. Imagine spending billions of dollars and millions of person hours designing a supercar. It's sleek, it's fast, it's a work of art. But then you put bald tires on it. Database services are like the tires of our company. They underlie every effort that those other brilliant people do, and it is my job to keep them running well. Over the decades, NVIDIA has been in business. We've built many tools and computer systems. In 2019, the majority of these systems relied on hardware hosted in a very old data center in Santa Clara. We decided to build a new data center that could meet our ever-growing and maturing needs. There were a lot of factors that went into that decision, but in the end, it was the right thing for the company. My team at the time supported several hundred database systems, hosting over 10,000 individual databases. These databases were the backbone for hundreds of individual applications. Many of these databases were tied to mission-critical processes. Nobody has unlimited funds for these types of projects. And while doing this migration, we still had to maintain a strict service level agreement. This was an enormous project, and we had 18 months to complete it before the lights went out in the old data center. 6 months into the project, the idea was presented to partner with Oracle Cloud. They had a data center, as it happens, that was physically near our new planned build. I evaluated the option of moving our MySQL and Oracle databases into Oracle Cloud versus moving them on-prem, which was our existing plan. A lot of factors went into this decision. costs of the services themselves in the Oracle Cloud, the licensing differences, the sunk costs from hardware we had already purchased and installed on-prem, engineering efforts around the automation of our standard services, which was already on our roadmap, integration between OCI systems and our on-prem inventory, network, and security systems, the ongoing maintenance effort once the migration was complete, coordinating the efforts with all of the various application teams that would be affected by this migration, and effort to level set our database and operating system versions as part of this migration. There was a lot involved in this. In the end, it made sense for us to pivot our plans, even though we were a third of the way into our migration window, and to begin this partnership with OCI. As I mentioned, we had a variety of applications that relied on our database services. These applications had their own existing roadmaps that could not tolerate a lot of interference during our migration efforts. We decided to keep the application hosts on-prem in our new data center and move MySQL and Oracle databases into the OCI San Jose region. The connection process between the two needed to be seamless, though. For our Oracle databases, we chose to use VMDB. We evaluated the other options of autonomous versus Exadata and determined that autonomous wouldn't work. We had several third-party applications that were constrained to do specific older versions of the database that weren't compliant with autonomous. Exadata would have forced us to create RAC. On-prem, we had already used standalone systems with DataGuard for our HA, and so we decided to continue that same approach as we moved into OCI, again, to have the least intrusive option. So Exadata wasn't a good fit, and VMDB ended up being our choice. For MySQL, we chose to use MDS hosting. We had already planned to level set our MySQL versions. On-prem, we had a variety from 5.1 to 5.7. But we decided to use this opportunity to level set on the current version of MySQL. Since that was the version MDS used, that aligned really well with our plan. We wanted to try HeatWave for some very specialized analytics workloads. I won't delve into this because there's another session planned that will address that topic. We decided to use full HA clusters for our production systems, and it was relatively simple to implement this in MDS. A massive benefit MDS provided us was the API calls that we could wrap into our existing process to perform most of our standard administration tasks. We would have had to create this ourselves had we used other implementations, and so having this available was a real boon for us. It was critical to our ability to move this massive footprint in the minimal timeline that we had. We'd already got Active Directory and Duo authentication implemented on-prem, so we decided to integrate that with the OCI identity domain for authentication. This allowed us to do several things. One, we could assign role-based permissions using Active Directory security lists, and in some instances, those lists the gatekeeper role for those lists could be handed off to the development teams, effectively left shifting that maintenance piece from my team. We have a full DevOps process at NVIDIA for most of our applications. So using AD integrations to assign different permissions to each role within development, staging, and production environments was also key to our success. Some of you may have heard the comparison between cattle and pets as it applies to system support. If you have not, I recommend doing a quick search. It's very enlightening and is key to the way that we support our infrastructure at NVIDIA. The idea is that rather than having snowflake systems with very specific hard-coded references that we treat like pets, we refer to our systems as entities within a service. So it doesn't matter if you're connecting to database system named 123 or database system named 456. As long as they are generally referable, it doesn't matter which is the particular one at any given time. This philosophy drives a lot of the choices that we made in our infrastructure. Since database services are key to creating all of the products that generate the money that pays our paychecks. Um, it's very important that we maintain a high level of service level agreement, SLAs. This is a highly competitive industry, and delaying time to market for our products can incur high costs in terms of market share, certainly more than I'm willing to write out of my paycheck. Much of our flagship product, much like what we do in our flagship product, the GPU, NVIDIA as a company has many simultaneous development efforts running in parallel. Some of them are delivering new chips, some are delivering drivers or other software solutions. Sometimes they're delivering whole new worlds, such as Omniverse. We have teams across the world that are constantly working on all these different tracks to keep them moving forward. And the timelines often overlap. Service interruptions for certain critical applications may block thousands of people from doing their work. In addition, we need to maintain point-in-time recovery. If something goes wrong and we need to roll back to a specific known good state, we must be able to do so. To do that, we back up bin logs as well as the actual database contents on the database side. We leverage Oracle functions and events to create a custom workflow around the process of switching over database hosts in HA clusters. This allows applications to maintain the same connection process they had, regardless of which individual host was actually the primary at any given time. Some applications, such as our automated testing and qualifying tools, have extremely bursty workloads. After a particular check-in, these will kick off thousands of individual processes that will each have connections to the database for kicking off and retrieving and storing test results. As you can imagine, if you have tens of thousands of these connections going on at the same time, adding even a 10 millisecond delay to each connection could result in delays of hours or even days in these processes, and that was just not acceptable. Because of the proximity of our two data centers, we were able to build 100 gigabyte fast connect between them and maintain an extremely low latency. We were also able to build up redundant connections to both improve our availability and to allow additional capacity for these high burst times. We also took advantage of the dynamic scale-up feature in OCI. This is not something we had available on-prem, but it was immensely helpful as we moved into the Oracle Cloud environment. Some of our data that we host is sensitive or has very specific compliance controls associated with it. To safeguard the data in transit, we encrypted all connections between the data centers with MACsec. This prevents any man-in-the-middle attack that may scrape data packets from the stream. We also use NVIDIA managed encryption keys with all of these OCI features so that we could comply with our internal security policies. And these are the methods that we use to comply with our ongoing SLA requirements. We chose a multi-tenant approach for our build-out. We have several reasons for this. One, we needed to be able to separate the roles of account administration from database administration, from application development, from infrastructure administration, and apply a minimum amount of security grants to each. That way we could maintain a high security standpoint. Storing universal resources such as security, network connections, governance, and monitor functionality in the parent tenancy allowed the child tenancies to inherit those without having to redo the same work. After our initial build out of building our database hosting resources, other business units at NVIDIA quickly heard about our relationship with Oracle and came to us with new use cases they wanted to try in this environment. Now we can host their work in other child tenancies where they have their own administrators, they have their own policies and quotas, and yet they can inherit all of the shared infrastructure that we build for our solution. All of these roles and silos are available because we had this integration with Active Directory services. And for each of the roles, we were able to provide granular permission for those individuals. We ramped up a large team from Oracle to help us deliver this on time. In order to reduce the security impact of having so many contractors working with our systems, we created jump hosts. These jump hosts allowed the Oracle folks to work directly with the destination and Oracle Cloud and the tools that were hosted on the jump host without having to expose permissions to all of the sensitive internal systems. Providing access to those systems to so many people would have been a much more intensive approval process, and we frankly didn't have the time to delay getting that approval done. For our MySQL migrations, we had two different paths. For the non-critical and non-production databases, they could allow some downtime. So we use standard MySQL replication to push the data through to our new targets. After the teams connected to the new targets and tested and made sure everything worked, then we could resync the data with a downtime and redirect the traffic, cutting it over using DNS references. For those other MySQL instances that were critical and less tolerant of service interruptions, we used Golden Gate to maintain data synchronization between the target and the source until such a time as they were ready to cut over. For our database migration, it was a bit more straightforward. The Oracle solution of zero downtime migration automated much of that work for us, and it streamlined the data transfer process. These tools all resided on the jump host, so they could reach both the source and target system. And that way, we could get all of our data out of our old data center, into the new. Automation was a key focus of our implementation. One of our emphasis in the support team is nonlinear staff growth. Our footprint can grow immensely quickly, and if we have to hire more people in a linear manner with our footprint, it's just not maintainable. The cattle versus pet approach that I mentioned before is integral to our ability to automate, which then allows for nonlinear staffing growth. At NVIDIA, our application development process flows through our environment from a development environment where developers have full ability to make schema changes and reset things and rebuild them until they're ready to release a good known state, at which point a production snapshot is hosted in our staging environment, and their changes are pushed to staging. We can test, do performance and functional testing there, so we understand the impact when we eventually push those changes to production. Production is much more locked down, and so we need to make sure that all of our tests succeed in staging before we advance to our production environment. And some of our data that becomes static but needs to be retained for various purposes eventually can move from our production environment into an archive environment. Through all of this, we don't have the luxury of relying on specific host names or Snowflake builds, because that would apply too much friction into this whole development and release process. Some of the choices we made for cost savings were enabled by our OCI build-out. Our development environment requires far fewer resources in terms of compute and storage. OCI allowed us more flexibility in terms of sizing options for these systems. Non-production systems don't need full HA. So again, we could customize the build for our non-production to have fewer systems and reduce the support cost. As part of this initiative, we matured the archive environment to a fully utilized environment. What we could do then is use low powered system with a static snapshot of the last production data that could be turned on demand for retention purposes. This becomes much less expensive than using a full production system as we did on-prem. This on-demand feature was brand new and very welcome. Being able to dynamically spin up and down non-production systems, which are not used all the time, is a dramatic savings to cost. Also, being able to automatically snapshot instances from one environment to another, say from production to staging, reduced the support time required to provide that service. Production systems require point-in-time recovery, as I mentioned. Some production data requires regular restoration to maintain government compliance. On-prem, we have the ability to provide this point-in-time recovery for only the most recent week. As we implemented our backup policies in OCI, we're now able to do point-in-time recovery for up to 15 days. On-prem, our backup process beyond this window allowed us to store backups offsite on tape, but the recovery process was very manual and slow. In OCI, we've implemented object storage of these backups and can automate recovery from backup to make it much faster and a low-touch approach for this regular occurrence. Let's take a little bit deeper look into our multi-tenancy architecture. For each tenancy, we needed to create a landing zone with a basic infrastructure in place. This allows us to spin up and down each team's project for just the duration they need. It empowers them to do their work, but prevents noisy neighbor situations that might otherwise impede other teams' work. The network compartment links to network resources in the primary tenant. The management compartment handles security, monitoring, and other utility functioning. This also draws from the primary tenancy. Beyond this, we create primary tenancies for each major use case. The first obvious one was the database team's use. We used nested compartments within the database services compartment to address our different environments. As other teams came into play, we could then create another tenancy or multiple compartments within a team structure if they had multiple solutions that they needed to support. For each of these, using this compartmentalization, we were able to assign permissions to each role in the appropriate compartment on an as-needed basis. Again, this helped us to maintain a higher security stance as we rolled this out. A large factor that measured into our ability to succeed in this venture was integrating OCI with our internal processes. We had existing tools in place for keeping track of our database resources that we had allocated and for hardware systems that we have provisioned. In OCI, we built some integration so that as new systems or databases were spun up, the automation would then keep the internal asset management systems updated as well. We also built automation around several key pieces. DNS updates. Because we need to maintain our cattle versus pet approach, we use DNS pointers to get to an individual system. That system may move around from an individual server or to a cluster or even to another location. And so automating the DNS pointers around those migrations helped us to reduce the need to keep pet systems. We have internal work process and internal provisioning processes that incorporate approvals and tracking of requests to make sure they're done in a timely manner. All of this was integral to being able to do the work in OCI and still have the processes work with our existing systems. Internally, we used Datadog as our primary monitoring system and had dashboards built out with NOC dashboards and interfaces and roll-ups. As we built out OCI, we essentially treated it as another compartment inside our existing infrastructure so that we could push that integrate the monitoring events into our existing dashboards and have take advantage of all of the same ticket creation and alerting things that we had in place. We have multiple cloud providers at NVIDIA, and each has requisition, approval, and reporting processes. Automating our OCI standard services and cost reporting was one of the biggest priorities so that we could maintain a uniform vision and so that we could report up through finance and executive staff on the usage of these resources. One of the key questions is utilization versus forecast. In OCI provides a 6-hour data usage data dumps, and we were able to pull those into our system, integrate them with our existing reports so that we could easily analyze them at all of these different levels to determine how well we were meeting our projected expenditures. So this was a large project for us, and there may be others that have similar efforts in the future. So some of the key challenges that we ran into that may be that Oracle may take advantage of to make similar interactions go more smoother in the future. For our key integrations, we built a lot of bespoke code around both the on-prem systems and the Oracle systems in order to be able to integrate our hardware, networking, and software solutions. We did a lot of knowledge transfer between the two, as this service and support model is significantly different than how we did on-prem. We have been able to capture those knowledge sessions and reuse them to train new people that came on board. All of this was driving a painless transition from our on-prem model into our cloud-based model. One of the service challenges that we ran into early on was there was a Sev1 ticket that was opened, and unfortunately it was assigned to a support person that went on vacation for a few days, and so the Sev1 ticket lay dormant until they came back. This was a key communication point where we were able to come together and address the way that tickets are created and followed through so that we don't have delays that would actually break our SLAs that we have committed to our internal customers. Even though MySQL is an automated service, some things require downtime. So we have worked with the support team to address areas where we need to test and do upgrades and patches outside of the normal automated window in order to not affect critical production systems. For feature enhancement, we've had a lot of coordination with various teams at Oracle, and those alignment conversations about upcoming features as well as past pain points have been invaluable. We've recommended some enhancements to OCI that align with our use cases, and it's been encouraging to see how the service itself has matured over the now year and a half since we've been engaged in this effort together. All of the work we did as part of this migration has laid a solid foundation on which we're able to now build additional use cases. We succeeded in exiting our data center on time, which was the #1 goal. We had very little service interruption, and we were able to quickly respond to any hiccups that came along the way. All of this leads to an incredibly successful engagement on this project. Now that that's in place, we can look at how can we leverage what we've built for additional uses. In my team, we have databases all over the world, not just in San Jose. This is an opportunity where we can look at some other regions and say, can we do the same journey there? Can we standardize more of our support for MySQL and Oracle to use the same services, the same code, the same efforts that we've just built for San Jose. In some instances, it makes sense to co-locate applications that the other teams at NVIDIA use with the databases that we service, especially in areas where there may not be data center on-prem space. Knowing that we've been able to address most of these concerns for our migration gives us leverage to work with those teams and identify opportunities for that. Beyond the database and application world that I live in, Oracle provides additional resources like GPUs and HPC. There are teams at NVIDIA that use these resources as well. And now that we have the foundation in place, we can work with those teams to find opportunities to build some of those processes going into the future. And you very well may hear more about this in the near future. I appreciate your time as we discuss the challenges and successes of this project. I hope that our experience proves useful to you as you address others' needs in the future, and that we can continue to leverage this partnership for both of our benefit going forward. If you'd like more information about this process, please feel free to coordinate through Riaz. Thank you very much for your time.